is Janet and Rabia.
Welcome to Everest Physics Academy.
In this video, we are going to determine the position of a particle using the curvilinear abscissa S. Calculate the distance traveled by a particle on a curved path. Relate the speed of a particle to the time derivative of the curvilinear abscissa. Solve an exercise about a particle moving on a circular path.
A particle M moves on a curved path. The position of M can be given by the curvilinear abscissa S of t equals the arc Im, where I is an origin on the trajectory of M. So the variation of the curvilinear abscissa of M between two instants t1 and t2 is given by S at an instant t2 minus S at an instant t1. If the particle M does not reverse direction or it moves in one direction, then the absolute value of delta S represents the distance traveled or the arc length during the time delta t.
Consider a particle moving on a curved path. This is the chosen positive sense. S is a function of time. If we want to find the value of the velocity, then we must differentiate S with respect to time. Then the value of the velocity is the time derivative of S. After finding the value of the velocity, if this value is positive, the particle moves in the chosen positive sense. Then in our example, the particle would move in this direction. If v is negative, the particle moves in the negative sense. Now consider this equation. We want to differentiate it with respect to time. The derivative of v with respect to time is v prime, and the derivative of s prime is s double prime. But what is v prime? V prime is the value of the tangential acceleration. Therefore, the value of the tangential acceleration is the second derivative of s with respect to time.
Now let's solve an application. A particle moves on a curved path. The curvilinear abscissa of this particle is given by 3t squared plus 2t plus 2 in SI units. Number 1. Calculate S of 0 and S of 3. To calculate S of 0, replace t by 0 in the expression of S. Then S of 0 equals 2 meters. Similarly, to calculate S of 3, replace t by 3 seconds in the expression of S. Then S of 3 equals 35 meters. Number 2. Write the expression of the value of the velocity of M, and then deduce whether M moves in the positive or in the negative sense. The velocity of M is given by the time derivative of the curvilinear abscissa, or v equal s prime. Given that if x equals a and a is a constant, then the time derivative of x equals 0. And if x equals at to the power n, where a and n are constants, then the time derivative of x equals na t to the power n minus 1. S equals 3t squared plus 2t plus 2. Then the time derivative of s equals 6t plus 2. Since v is positive for any value of the time, so m moves in the positive sense.
Focus, please. This is important.
Let's move to part 3. Deduce the average speed of the particle between time 1 second and time 4 seconds. As we have seen in the previous slide, m does not reverse direction. Then the absolute value of delta s represents the traveled distance. Now, replace t by 1 second in the expression of s. Then, s of 1 equals 7 meters. Again, replace t in the expression of s by 4 seconds. Then, s of 4 equals 58 meters. Now we are ready to calculate the average speed, which is given by dividing the traveled distance over the time. Now, the travel distance is the absolute value of delta s, which is the absolute value of s at time 4 seconds minus s at time 1 second. Delta t equals t final minus t initial. Therefore, the average speed is 17 meters per second between these two instants. Let's move to part 4.1. Determine as a function of time the distance traveled by m during a time 0t. Again, the traveled distance is the absolute value of delta s, but we use only delta s because the particle is moving in the positive sense. Delta s equals s at time t, which is the final instant, minus s at time 0, which is the initial instant. S at time 0 equals 2 meters. It is easily obtained by replacing t by 0 in the expression of s. Now, to determine the expression of delta s, just subtract 2 from the expression of s. Therefore, delta s equals 3t squared plus 2t, and it is expressed in SI units.
Number 4.2. Using the expression of the distance traveled by m, determine the time needed by m to travel the first 50 meters and the second 50 meters. Let's start with the first 50 meters. Delta s equals 50. So replace delta s by 50 meter in the above expression. Then we get this equation. 3t squared plus 2t minus 50 equals 0. Using calculator, t1 or the time needed by m to travel the first 50 meters is t1 equals 3.76 seconds. Now to determine the time needed by m to travel the second 50 meters, let's use this diagram. T1 is the time needed by m to travel the first 50 meter. Let T2 be the time needed by m to travel the first 100 meter. So the time needed by m to travel the second 50 meter, and using this diagram, this time equals T2 minus T1. Now we have to determine T2, or the time needed by m to travel the first 100 meters. Delta s equals 100. So replace delta s by 100 in the above expression. We get this equation 3t squared plus 2t minus 100 equals 0. Using calculator, t2 equals 5.45 seconds. Now we can determine the duration of the second 50 meter, which is equal to t2 minus t1 equals 1.69 seconds.
Let's move to part 5. Determine the magnitude of the acceleration vector at time 2 seconds, knowing that the radius of curvature at time 2 seconds is 10 meters. To calculate the magnitude of the acceleration vector at a certain instant, we need to find the values of the tangential and the normal accelerations at this instant. Let's start with the tangential acceleration. It is equal to the time derivative of the speed. Let's differentiate the expression of the speed with respect to time. The derivative of 6t with respect to time is 6, and the derivative of 2 is 0. Then, A tangential equals 6 meters per second squared. A tangential is constant, therefore it has the same value at any instant. Then, A tangential at time 2 seconds equals also 6 meters per second squared. Now, before calculating the normal acceleration, let me calculate the speed at time 2 seconds by replacing t by 2 in the expression of v. Then, the speed at time 2 seconds equals 14 meters per second. The normal acceleration equals v squared over r. To calculate the magnitude of the normal acceleration at time 2 seconds, we need to divide the square of the speed at time 2 seconds by the radius at time 2 seconds. The speed at time 2 seconds is 14, and the radius at this instant is 10. Therefore, the normal acceleration at time 2 seconds equals 19.6 meters per second squared. Now we know that the acceleration vector is the sum of the normal and the tangential component vectors, and they are perpendicular to each other. Therefore, a squared equals a tangential squared plus a normal squared. Now, at time 2 seconds, A tangential equals 6 meters per second squared and a normal equals 19.6 meters per second squared. Therefore, the acceleration at time 2 seconds has a magnitude of 20.5 meters per second squared.
Thank you for watching. If you like this video,
Subscribe to the channel, hit the like button and share.